Hello, guys, and welcome to part one of my introduction to software engineering series. My name is Marcin Hoffman, and I will be instructing the video today as well as explaining the topics that we cover in the video. The goal for the series will just be to inform anyone watching on some fundamentals, some basic concepts of software engineering, as well as to provide some real world perspectives, some examples, and some relation to what can be seen in the field of software engineering as a whole. Now let's get started. First, in the first entry of the series, I want to be defining software engineering. I want to be giving you guys some background information on the field as a whole and also some characteristics of it. First off, let's get familiar with engineering. Now, the concept of engineering is going to be the application of scientific principles and methods to the construction of useful structures, systems, or machines, etc., right? Now, when you specialize this and you focus it down, you get software engineering or specific types of engineering. So in our case, it's going to be software engineering with the development of software systems and the application of scientific principles, methods to develop these software systems. Also, another key characteristic of software engineering, it's going to be the size and complexity for these systems or whatever really is being developed. Now, 99.9% of the time in software engineering, it is not an individual developer thing. It's going to be a team of trained engineers who handle these issues. Now, even more so, it's going to be multiple teams with a lot of managerial oversight. It is what makes software engineering so complicated and so difficult to grasp. It is the enormous scale of what these people are trying to produce. Now, I could see how it's going to be difficult to differentiate between software engineering and software programming, which are quite similar. But I assure you that software engineering is an entirely different thing when you look at it. Now, a good example of how to differentiate between these two, it's going to be the scope of what software engineering is going to encompass. Now, on any given project, there is a multitude of variables that you need to account. Some of these may include the software process, the development principles, the techniques, the notations to consider, the effort estimation costs to consider, the man hours that are required, the available resources you have for a project, and so on. And this is just a small part of what is seen when you're exploring software engineering or trying to tackle a challenge within software engineering. Now, on the other hand, you have the overall end goal of what every good software engineer needs to be able to do, or what any team of software engineers do, and that is going to be the production of high quality software within timeframes, within budgeted manners, within customer requirements and or user requirements. Now, this is so important, you guys. It is crucial for software engineers to produce high quality products. It is catastrophic when things go wrong with software. It can become quite a bad situation, honestly, when you have products of software engineering that are not reliable, that are not up to par and not up to standard, right? Now, many of you may be asking yourselves the questions of why we should care about this, why we even need it in the first place, or how any of this is relevant to you as an individual. Now, to kind of relate that so you can kind of apply that to everyday life, it's going to be that software and systems are essentially what prop up modern developed economies. It is if software systems were to fail, then economic instability would take over in seconds, you guys. It would be quite devastating to modern economies of software systems and software engineering, where all of a sudden just stop happening. Now, also a significant portion of national income in most developed nations is tied to their software development and its related expenditures. That's why so many countries strive for solid software engineering individuals, for the education of software engineering. Also, when it comes to the development of modern industries, for infrastructure, for technological services, they are becoming increasingly software controlled. Essentially, the role of software right now is the driving factor for productivity. It's what drives innovation in countries, and it's only continuing to grow. However, with this leads to dependency. Now, why this matters for you, as this dependency means failures and or setbacks are radically damaging to everyday individuals. Now, to kind of give you an example of what I'm talking about, is we can think back to the recent IT disaster in July of 2024 with CrowdStrike, where 8.5 million personal computers were completely destroyed and crashed, which cost globally around the $5 billion mark. Now, this entire disaster was caused by a simple faulty software update that CrowdStrike released, and could have easily been caught and fixed. But this is just one example of how impactful software and the people behind it are. Now, this is an example of individuals, people who had nothing to do with software engineering or had no involvement in it, but were still affected by what is going on in the field itself. Now, many of you have seen the massive increase in data sets that are present within our everyday lives. It has been a very raging modern topic now. And for software engineering, it is one of the largest systems. And when you look at it through a software engineering approach, you're taking into account its scalability, its performance, its management of those large systems, the expanse to store it, such as in terms of technological infrastructure, with these massive data sets. And it's just another example of how crucial software engineering and what role it's playing. Also, we as software engineers face constant threats, and that they're constantly different. It is an ever evolving game for software engineers. One of the other big things is going to be cybersecurity. It is crucial that the information, like for example, if you were to take your bank info, that's stored online. It is stored in some kind of infrastructure. Software engineering is what enables you to keep it safe. Now, the kind of going back to that overall goal of what software engineering is trying to do, the assurance that software engineers can give out reliable, efficient systems and to provide solutions for these everyday experiences. And this ranges from individuals such as you or me, or to these massive corporations who rely on software engineering for everything they do, essentially, is what I believe makes software engineering such a great topic and such an interesting field to learn and to discuss about. So to kind of wrap it up, that's going to be it for this first part series. I appreciate you guys for tuning in and listening. Please like and share if you haven't, and I will see you guys in the next part.